Welcome to the Digital Metrology Standard Consortium's coffee chat. Today's in August, our topic is Introduction to C++ for QIF. And it will, our speaker is Tom Kramer, who is a NIST guest researcher. Next slide, please. While we're doing this, we have some housekeeping. I just want to make sure everybody's aware of the housekeeping rules, right? We'll have you in participant, you'll be in listen-only mode, and you'll be able to submit questions in the question box on the control panel, as you can see in the picture right there. Thank you. You may send questions at any time during the presentation. We'll be collecting those, and at the end of the presentation, we'll have a Q&A section. You will receive this presentation as an email link, so it'll be recorded, so you don't have to keep copious notes. If you have any questions, just please put in the dialog box, and I will respond to it. Next slide. So without further ado, here's Tom Kramer.
Thank you, Ray. As Ray said, we're talking about C++ for QIF today. I was a guest researcher at NIST for a very long time, but I am now retired and am working as a consultant. I've been helping develop QIF for a bit over 10 years, and I've also done a lot of software development. I want to mention first that there are a lot of free public resources that you can get about QIF. The first essential thing for QIF is the standard itself. And this is showing where you can get the QIF download. That download includes the XML schema model, a large text document, and the XSLT constraints. In addition, there are a lot of resources available on the QIF community site. And the first one of these is the Schema Browser. It's all in HTML, and it lets you navigate the model. There are also some new tools here that were contributed within the last couple of weeks. One is the QIF Validation Tool. You can download that and use it to validate QIF3 instance files. I should mention right now that instance files really are also called data files. Sometimes they're called document files. So QIF instance file is the same as QIF data file, is the same as QIF document file. And there are a lot of sample instance files available on that website. Another new tool is a QIF Rules Editor. One part of QIF is rules for how you do inspections. The model itself is difficult to understand, but an editor has been written that makes it easy to write a rules file, and that's available. Similarly, you might have a QIF instance file with resources in it. That's the equipment that you're using to do your inspections. So you might have a QIF instance file with nothing in it but resources, and then you can reuse that file whenever you need to make a QIF plan. And this new application helps you write resources file. Then there are a whole lot of source code bindings. That includes C++ classes for QIF, but it also includes a couple of examples of code built using classes for QIF. And it's not only C++, it's also got Python and C#. Then you can get to the QIF tutorials also through the QIF community. There were a series of 3 tutorials given about a year ago. They're called QIF 101, 201, and 301, getting more technical as you go. Those are available. So, what is QIF? For starters, it's a standard. You can download it, it's well documented, it's stable. There may be future versions of QIF, but 3.0 will always be 3.0. And the scope of QIF 3.0 is quality, model-based definition, plans, resources, rules, results, and statistics. And this, what we call the QIF lifesaver, illustrates that. You're not required to use the parts of QIF in any particular order, but one typical order is to import a QIF model-based definition from a CAD system, then make a plan for how you're going to do inspections in more or less detail. Then you would add resources to your plan. You may have rules that you use when you're making the plan. So once you have a detailed plan, then you would go to programming. Now, DMIS is a programming language for CMMs. It's not actually part of QIF, but it's closely linked to QIF. So you can use DMIS with QIF. So you do your inspection and you get results out of that you can put in the QIF results file, and then you can process those results as statistics. And most common use of statistics is for process control. All of this is in XML schema definition language. For each of these major areas, there is a separate schema file. But in addition, there are a whole lot of resource files describing things. For example, features and characteristics are in the library. Even though features and characteristics are 2 of the largest parts of QIF, they're not separate applications. And all the other applications draw on items that are from the library. And the data files or instance files are XML files. Those XML files are governed by the model. There are rules for how an XML file conforms to a model. And to have a valid QIF instance file, that file has to conform to the QIF model. In addition, there are constraints that can't be expressed in XML schema definition language that can be expressed in XSLT. So QIF includes a set of constraints written in XSLT that also must be satisfied. And QIF is big. If you tackle QIF, be prepared to deal with a lot of information. So, Ray, you want to run the first poll?
I'm glad to, yes. So our first poll is, are you building a QIF application in any language? And your pick one, and the choices are Not yet. No plans to do so. Don't know why you're here. Not yet. Planning to do so. Yes. Working on it. Yes. Ready and using privately. Yes. And available to public purchase or freeware. So if you take another 30 seconds here and vote, we'll close the poll. All right, get in there and make your votes. We're going to close the poll in just one more second. And let me share the results. So looks like 64% are planning, not yet, but are planning, and 18% are yes, working on it. All right, thank you.
That's everybody?
That was everybody.
Okay, thanks, Ray. So if you're planning, this is a good tutorial to be listening to. So if you're planning to support QIF, what do you need to do to support QIF? Basically, that means that you've got software that will read or write QIF documents in XML format. And all QIF documents, as I said a minute ago, have to be valid against the QIF data model. That's the XML schema file. And also valid against the QIF XSLT. So how do you get started? Well, you download the standard. That includes the big text document, the schema file, and the XSLT. Much as many people don't like to do it, you really need to study at least some of the text document, particularly the parts of the text document that talk about what we call the aspects of features and characteristics. There are 4 aspects. It's definition, which contains basic information about a feature or characteristic. Nominal, it contains more specific information about a feature or characteristic. That's where you get the complete description. Then there's item, in which you specify details associated with how you're going to inspect that feature or characteristic. And then finally, there's results. We call it measured. So the 4 aspects are definition, nominal, item, and measurement or measured. And you need to study the text doc to get the idea of those. And there are other things that you have to study the text doc for, because even if you spend a lot of time in the HTML documentation, you won't get it. There are diagrams in the text doc that are helpful. After you've gotten your feet wet in the text doc, or really you can do it in any order, study the HTML. And the best place to start with the HTML is in the left-hand pane, you'll see a list of gazillion items. The first big list is elements, and if you go to QIF document element, that's the best place to start. So after you've got a big idea of what QIF is all about, then if you're building software, you got to decide on an approach. You could just write a program that starts printing QIF documents. That's not recommended. You could try to use XPath to deal with strings of paths through your document. You could use a document optional a document object model, the DOM model, or you could do source code bindings. And really the only one of these that makes a lot of sense is using automatically generated source code bindings. You could write your own C++ from scratch, but that would take forever. One reason that QIF is written using the HTML schema definition language is that there are many utilities that will read the model and generate code for you. The code that gets generated lets you read and write files, and it usually includes a skeleton parser. So the only serious choice is source code bindings, and you don't want to write your own. Systems that will generate source code are available in a number of languages, including at least C++, C#, Java, and Python. Today we're only talking about C++, but you should be aware that you've got a choice of what language to use. So how did the C++ classes relate to the XML schema definition language model? Well, XSDL is really a class model, but they don't use the term class. They use the term type. And there are two types, simple types and complex types. And both of those map directly to C++ classes. So any C++ generator you use will make a fairly direct mapping from simple and complex types to C++ classes. And XSDL, in each type, you can have elements and attributes, which are really two names for the same thing, but they're different syntactically. And both elements and attributes map to fields of C++ classes or members of C++ classes, depending on what terminology you want to use. And the C++ class hierarchy mostly matches the XSDL type hierarchy. Both XSDL and C++ let you derive more specialized classes from more general classes. And in the QIF model, some of these hierarchies are 6 or 7 levels deep. So if you run the XSDL through a generator, you're going to get C++ classes in which the hierarchies are equally deep. Now, XSDL has primitive types, things like strings and integers and booleans. And those things are also available in C++, but in general, there's not an exact match between the XSDL primitives and the C++ primitives. So generators will provide C++ classes also for the XSDL primitives. XSDL primitive types are actually in a hierarchy, although it's not particularly important information. In general, the corresponding C++ types for the primitives don't need to be in any particular hierarchy. XSDL is only data and constraints, but in C++, you need more things in your program to do real work. So the C++ classes add the obvious thing, constructors for making new instances of things, destructors to get rid of them, and access functions for retrieving elements and attributes of types. All right. So what's available in the way of C++ class models? One, and there are three choices here. One is get a commercial generator and generate your own classes. That may require minor changes in the QIF model. Most of the commercial generators have problems with some parts of C++ model, of the QIF model. So be prepared to fiddle with the XML schema definition. The changes shouldn't be extensive, but they may be needed. So a few generators that are commercial that you can get. One is Code Synthesis. Another one is XML Spy. I downloaded the most recent XML Spy just a couple days ago and generated code for QIF with their code generator. You can get a free license for XML Spy for a month if you want to test it out. And Oracle claims that they have a C++ generator. I read it just the other day in their programmer's guide. I haven't attempted to use it, and I have not heard of other folks who have used it. So that's the first choice. Second choice is there are a number of freeware generators out there. You can generate your own classes with a freeware generator. And I'm very prejudiced here because I wrote one of the freeware generators. It's named XML Parsers and Utilities, and you can get it from SourceForge. If you use that freeware generator yourself, you should use the QIF model available at the website showing on the screen. The reason for that is there are some unnecessarily complicated structures in the current version of QIF 3.0 that can be simplified. And this generator is not particularly happy with some of the more complex constructs, but they're not needed. So you get rid of the complex constructs. I know this one works on QIF because I've used it to generate the QIF code. There are a couple other freeware generators that I located. I have not tried them. I don't know how well they work. And there are probably more out there. My guess is that you will have trouble if you use other freeware generators because QIF is so big and complex. And finally, you can just download the existing QIF C++ class model from, excuse me, the QIF community site. So there's an existing model that you can get. Let's see. And this model has C++ classes for all of QIF. It's HH header files and code files. QIF includes the schema file that we imported from a non-QIF source, which is the signature schema file. The signature part of QIF allows you to put code into your model that includes a checking value. And if any character, even one character in a QIF file is changed afterwards, that code won't be regenerated. So the signature enables you to check that nobody's messed with your QIF file. But implementing the signature is quite complex. So this particular code treats the signature just as a string. You have to find additional code to do something with that string. As I mentioned earlier, you need to have C++ classes for primitive data. And you can either generate that with some generators, but in this case, there is a model of these primitive data classes that was manually programmed. But you could use it with really any XML schema model. It's not specific to QIF. And then there's a parser there that lets you parse an instant file into an abstract syntax tree. That's a YACLEX parser. And you can write the tree back out again. The files included with the classes have files that print classes out. So once you got a tree built, you can print it right out. And then there's a minimal application that just reads the file in and writes the file out. So those are the three choices for getting your C++ classes. And Ray, can you run poll 2?
Poll 2, I'm watching now.
Yeah.
Here we go. So are you using a C++ model of QIF? And your selections are no, yes, the one for the QIF community, from the QIF community site. Yes, a code generator like code synthesizer, XML Spy, Xarea C++. Yes, but from another source. So please take it right now and vote. I'll leave it open for about 20 more seconds, and then we'll see what everybody's voted on. All right, if you haven't, vote now. I'll give you another 5 seconds. All right, and what are our results? 85% no's, 5% yes, 10% using branded XMLs, and 0 from another source.
Okay, so I hope many of you folks out there are C++ programmers, but obviously not too many people have got to start yet. So that's fine. Oh, and you can also get a makefile from the QIF community site. There is not a Visual Studio project set up for this set of C++ classes, but it should be fairly straightforward to set one up. So whatever you do for getting your C++ classes, be careful. If you use a commercial generator, make sure you read and follow their license. The software that is available on the QIF community site is provided as is, and there's no warranty about it. And DMSC itself doesn't endorse or recommend any particular source code generator. So in general, the source code binding generators automatically create classes from schema files. And here's some actual code. The schema definition, for example, has a simple type definition of a point. And this is called point simple type, and it's just a list of doubles with 3 values. When you run that through a generator, you get something that looks more or less similar to what's showing here on the right. Now you've got a class rather than a simple type. And there are a lot of sets of double colons. That's mainly for namespaces. But what you get is you get a bunch of constructors. There aren't any constructors written out here. Oh, I'm sorry. No, these are constructors. Yeah, these are 3 different constructors. So that's an example of what a generator generates. What none of the generators do is implement the key and keyref checks. There are many hundreds of key and keyref checks that are included in the QIF model. And when you build your software, you will want to make sure that the constraints that the keyref and key checks express get implemented. Otherwise, you simply will have software that won't work well. But the generators won't generate it for you. You've got to generate it yourself. So as I said earlier, I ran the QIF model through the most recent version of XML Spy to generate code. Now, most generators have a number of options. That's true of the generator I wrote also. In XML Spy, you have a choice of generating code that's tailored to either Microsoft Visual Studio or to Apache Xerxes 3. This code uses namespaces heavily. There's always a problem with name conflicts when you're mixing a large quantity of code with your own code. So it's hard to avoid name conflicts. XML Spy does that by using namespaces heavily. The code itself makes some use of templates. All the code showed up in 4 different directories, but there was a lot of code. Over 2,300 header files, for example, for QIF document. And there were over 80,000 lines of actual code. The CPP suffix code. That's actually probably a gross understatement because the code that is generated is built for using a lot of Microsoft code. Oh, the code I generated was for Microsoft. I didn't try the Xerxes code. So there's a huge amount of Microsoft code that automatically gets used with this. And in the case of XML Spy, the code for the data types is generated. It's not prepackaged. And the code allows XSI type. XSI type is it's part of the XML schema definition language that lets you declare that one of your elements has a generic type. But when you actually write an instance file, you can use one of the derived types for that generic type. But if you do that, you have to put in an XSI type declaration that says what the type is that you're using. So the code generated by XML Spy includes a lot of code for XSI type. And there's a skeleton application. I think it's just a read in, write out application. I did not try to build it. But let me say a little bit more about XSI type. The QIF model was built so that you never need to use XSI type. An alternative, if you want to use a derived type of a general type, is to use what's called substitution groups. And the QIF model makes heavy use of substitution groups. Does not use XSI type anywhere. I don't think it's actually in the big QIF book, but you should never use XSI type with QIF. And in the next version of QIF, whenever that is, I hope we will be very explicit about that. So here's just a sample of a constructor that was generated from XML SPI. It's the usual kind of constructor if you're used to C++. There's the constructor name. And this particular constructor uses another instance of flatness characteristic definition type. And so this is a copy constructor. So the first thing that it does is it calls the constructor for its parent type, which is form characteristic definition base type. And to do that, it calls this thing other get node. Other is the other instance that you're copying from. And then it sets a bunch of values. So other than the other get node, this is a very typical looking copy constructor. So let me switch now to the code that you can get from QIF community. First of all, it's generic C++. It's not specific to any other software. It's just pure C++. You can use it with Visual Studio. You can use it with Linux. Anywhere you can use C++, you can use this set of classes. Rather than making heavy use of namespaces, there are rules for for constructing names that avoid name conflicts. It doesn't make any use of templates. All the code is in one directory, but there are a lot of header files and code files, and there's a huge amount of code. Over 686,000 lines. The model of the primitive data types is in a completely separate file that is a fixed file. It doesn't require any building. Called XML Schema Instance. And this set of classes was generated with access functions that have prefixes of get and set. You can get a value for an element or an attribute, and you can set a value for an element or attribute using all these get and set access functions. And it doesn't allow XSI type. I have generated code for for the QIF3 model in C++ that does allow XSI type, but I'm hiding it away under my bed. And it's about 40% larger than the code that doesn't include XSI type. And the parser is written with YAC and LEX. If there are errors at exits, then it's probably something I should modify to do a throw on when an error is encountered. But that's an overview of what the C++ code you can download directly includes. And then here's a sample constructor. This is a constructor that is using data for each element. It's not a copy constructor. This particular code lets you use the default copy constructor. So there's no specialized copy constructors. But in general, there are 3 constructors for each class. And one of the constructors for each class takes values for all of the elements and attributes and sets them. So once again, you have a name for a constructor, a whole bunch of, in this case, a whole bunch of arguments. This is all of the elements of the flatness characteristic definition. Once again, you call the base type constructor with those arguments that the base type constructor uses, because these things are elements of the base type. And then you set those elements of the flatness that are specialized to flatness. So that's sort of a typical view of a constructor from this code. Now, I mentioned before that there are also some applications in the QIF community. And if you want to build C++ implementation of QIF, studying these sample applications, we think, will be very helpful. There are 5 different ways of building the same QIF instance file. There's a C# method, a Python method, and 3 C++ methods. One of the C++ methods uses code synthesis code. And 2 of them use the code from the QIF community that you can get. So what do? They write a QIF instance file with a plan for inspecting an object that looks like this. And this has got a perpendicularity constraint and flatness and position. And it's got a number of diameters with constraints, tolerance constraints. And they produce a QIF instance file that looks a lot like this. Well, I won't go through that, but there's an identifier for the file as a whole. That's this Cupid thing. And there's a header for the file. There's a bunch of datum definitions, datum reference frames, some measurement resources, some features, some characteristics, a very simple plan, and some results. So the file that gets produced by this sample C++ code looks like this. So what do these applications do? They set up units, they define datums, define datum reference frames, they give definitions for feature definitions, nominals, items, and measurements. They hook the features to the datums. They give characteristic definitions, nominals, items, and measurements. So in this case, we're pretending that the plan has been carried out and you actually have measurements available. They define measurement resources, they give a trivial measurement plan, and they generate a valid QIF document, instance file, data file, whatever you want to call it. So that's what these applications do. And here's a little bit of information just showing things that you would see in the generated file. You could actually fiddle with these applications by changing the data without changing anything else, and simply put substitute data in where you want. So it's not only an example, you can fiddle with it too to learn. In the applications using the free open source binding, there are two methods are shown in different C++ files for how you can use this. Both of them connect objects with pointers. One version uses new to make objects. But if you do that, the simplest way to avoid getting confused is don't reuse references to objects. If you have two references to the same object, build them independently. And the other uses automatic variables. So if you read through those files, you see they look quite different because of these two approaches. And I think I'm done. I don't really know if I've taken too much or too little time.
No, you're right on schedule, no problem. So I just want to remind everybody to write in your questions. We'll read them off. If there's no questions, we'll wrap up the meeting. But we do have a few already in the queue, so let me start this. So the first question is: will all semantics references be retained? Now, some references are lost when exporting to step AP242.
This is really a question about the relationship between QIF and STEP. There are automatic converters. CatVidia provides a tool called MBD Vidia that will translate back and forth between AP242 and QIF. And you have a choice between QIF 3.0 and 2.1. So that question can really only be answered with respect to a particular converter. I think that converter retains all semantics going both ways, but I'm not prepared to write my name in blood about that.
Okay. Well, and I would second your statement. I think you're right. It does do that. This next question: what is the application reading to produce the output? A step file? And this wasn't when you were on slide 20.
The applications that is the C++ sample applications that are available don't read in anything. They create data from scratch. So the C++ calls create the data, and they arrange the data appropriately in a QIF model. So there's no translation involved. It's generating from scratch.
Would it be safe to say that actually QIF isn't really an application? It's more of a file system, and that applications. The C++ is you're binding to an application, so that it depends. It could be a metrology, it could be a model, it could be a CAD model, it could be a number of different applications.
Yeah, I guess that's correct. You can do a lot of different things with the C++.
Right.
You don't have to read in anything. You can generate from scratch. But the C++ that's available from the QIF website says nothing whatsoever about STEP.
Okay. Next question. How does the QIF Schema Browser work?
Let me find that. So here's what the QIF Schema Browser, here's what the QIF community website looks like. And if you want to use the Schema Browser, that's the first choice here. So let me point out that these other resources that I mentioned are available in the same place. There's the validation tools, sample instance files, rules editor, resource editor, and source code binding. And there's other stuff as well. But if we go to the browser, over on the left, there's this giant laundry list, or table of contents, and there's a big long list of elements. So the best place to start if you use this browser is with QIF document. And that's relatively easy to find because it's the only item that begins with Q. So what you see when you click on that is this picture appears. And so the QIF document is here, and what this is saying is the QIF document has all of these elements, and it also has attributes. As I said, elements and attributes are both equivalent to C++ field. The attributes don't have substructure, but elements can have substructure. They're not required to. So if we go down to something like datum definitions, you click on datum definitions, and this says basically datum definitions is a list of datum definitions. And there's an attribute n that says how many are in the list. We click on datum definition, we get this picture showing up. So we can navigate down through the model, and then we can navigate back again. So by clicking the back arrow, we get back to QIF document. So that's how the Schema Browser works. And if you're interested in QIF, I encourage you to use it.
Next question. What sort of constraints are handled by the XSLT?
The constraints that can be handled with keys and key refs mostly concern identity. They can't count things. Like that n that we were just looking at, it gives the number of entries in a list of datum definitions. You can't check that using a key or key ref, but you can check that using XSLT. So a whole lot of the XSLT checks are checking that n value. There are other checks having to do with the details of B-splines. And then there's another issue with keys and key refs, and that is keys and key refs can only check items that are in one file. QIF is set up so you can use multiple instance files together. You could, for example, have all your resources in one QIF file that you've seen, and you reference things from that file in a results file or a plan file. The XSLT lets you check a lot of identifiers between a base file and an external file that the base file is using. There are several hundred checks that basically duplicate the keys and key refs that apply within a single file. So there's those generic kinds of capabilities that are in XSLT that you can't get with keys and key refs.
Okay. Yeah, I have one more question for you. So is creating a relational database schema tables possible from the XSD schema files?
I believe the answer is yes, but I have not tried it. I think the automatic generators may do that for you, but I have not investigated that. There are a lot of capabilities in XML Spy. I should mention another product, just to be fair here. There's a product called Oxygen XML that also has a generator. And both Oxygen XML and XML Spy have a lot of capabilities in addition to code generation. And I would expect that relational database tables are included, but I have not examined that.
Okay, that concludes our questions. Unless there's anybody who wants to give last questions in, why don't you go to the next slide, and I'll that concludes today's presentation, unless we get a pop-up here. So I just want to remind everybody as we're wrapping up today's meeting. First of all, thank you, Tom. Excellent presentation. I've learned a lot. Next month, we have our coffee chat in September. We'll be planning your model-based journey presented by Jesse Zenner from Sigmetrics. That should be really interesting. And if you want to register, we actually have that registration open now. You can go to qifstandards.org/events, and if you go to the September calendar, you can enroll, register there. And when you get the presentation tomorrow, that's the hyperlink directly to registration on the bottom. So that concludes today's presentation. Thank you very much again, Tom, for your presentation, and thank you today. Everybody have a great day, and hope to see you in September.
My pleasure.